Hello and welcome to Nkumat Online Academy. Today we want to learn how to balance chemical equations. The goal of balancing chemical equations is to make sure that the total number of atoms of each of the elements on the left-hand side of the equation is the same as the total number of atoms of the elements on the right-hand side of the equation. So if you have different elements, let's say that we have A and B. Reacting to give AB. Our goal in balancing chemical equation is that we want to make sure that if we have, let's say, 2 atoms of A, on this side, we are also going to put 2 atoms of A. So we find a way to also put 2 atoms of A. And if we have 2 atoms of B, there must also be 2 atoms of B on the right hand side. So the total number of atoms for each of the elements here must also be the same as the total number of the atoms on the other side. Now in doing that, we count the coefficient and the subscripts. Now that means that if we have assuming we have A plus B to give us a compound that looks like this: A, B. Here, this indicates that the atoms of A is 2, but the 2 atoms, the 2 is written as a subscript for A. So we are now going to put A here to balance the equation. We put 2 this place. That now shows that we have 2 atoms of A this side. For this one, if there is no subscript attached to the atom on the right hand side, you should never put any subscript on your own. Anything you are balancing should be as a coefficient for this side and even this side. So if the element is not written with a subscript, you should not put it. But if it is written with a subscript, you should count the number of subscripts as the number of the atoms. Now let's look at some examples to make it clearer. Now let's assume that we have this equation. Let's start with a simpler one. We have Let's start with the formation of water, how water is formed. Hydrogen molecule and oxygen molecule reacting to give water molecule. Now here we have hydrogen molecule, that is H2, and we have oxygen molecule H2. these two, H2 here, assuming that there is no 2 here, we should not put anything here. We should not touch this side in balancing the equation. Anything we want to put is going to be at the back of the element or the atom here. So we should not put anything as a subscript when we are balancing the chemical equation. So here, this one indicates that we already have two hydrogen. We already have two hydrogen atoms here, and we have two hydrogen atoms here. But oxygen, we have one oxygen here, and we have two oxygen this place. So we have to balance it by doing something that will make the oxygen to be 2. Now, I said that we cannot touch this place, so we cannot put anything this side. If you don't know how to balance chemical equation, you may decide to put something here. You cannot do it. You cannot write anything in front of the atom. So this place, we cannot write the 2. We can only write the 2 at the back of the compound. And if you write anything here, it will now change the hydrogen to 4. But that is the only way we can balance the chemical equation since we cannot write this place. So we put the 2 here. We put the 2 here, and that becomes 4 hydrogen, because this 2, you are using it to times this one. You use the coefficient to times the subscripts. So the hydrogen becomes 4 and oxygen is now 2. Now, since hydrogen is now 4, we now ask ourselves if there's anything we can do to the hydrogen this side to become 4. Yes, what we can do is to just put 2 here. If you put 2 at the back of this one, it will now become 2 times 2 also, which is now 4. And this one is now 4, 2. So everything is now balanced. So we have 4 hydrogen here. We have 2 oxygen, and we have 4 hydrogen and 2 oxygen. So the equation is now balanced. The total number of atoms of hydrogen on the left hand side is now equal to the total number of hydrogen atoms on the right hand side, and that of oxygen is also balanced. So this is how to balance chemical equation. Now let's look at example 2. Okay, we have calcium hydroxide plus ammonium chloride. Now this giving us ammonia, and water, and calcium chloride. Now how can we balance this chemical equation? Remember, our goal is simple: to make sure that for each of the atoms on the left hand side, we have equal number of the atom on the right hand side. Now we start with the first atom, calcium atom. We have one calcium atom here. We have one calcium atom here. This one that is put in brackets, it means that two of them must always go together. It is called a radical. When two atoms always go together, like SO, SO4 2 minus. This one is hydroxyl, which is OH minus. They are called radicals. They always go together, so when we are using them or we are writing them in a compound, we always put them in brackets to show that two of them go together. But still, in balancing the chemical equation, we make sure that the atoms in the radicals are balanced very well. So we have this one, 2 outside the bracket shows that we have 2 atoms of oxygen and 2 atoms of hydrogen. The 2 will times whatever we have here and also times whatever we have here. So we have 2 atoms of hydrogen and 2 atoms of oxygen. So we come here, we have oxygen 2. Then we come to the right hand side, we have only 1 oxygen, but we have 2 oxygen here. So we will have to do something to balance the oxygen. Now what we can do to balance the oxygen is that let's put 2. Let's assume that we have two here. That is 2 atoms of 2 water molecules. Now, if we have that, the oxygen is balanced. Now, let's go to hydrogen. We have 2 hydrogen. So, hydrogen is 4 now. Hydrogen is 4. Why hydrogen is... The total number of hydrogen is 2 here, to this side, plus 4 here, which is 6. But we have 2 hydrogen here. So what can we do to make sure that it is balanced? Okay, we have 2 here and 3 here, which is 5. We have 5 here and we have 6 here. So what can we do to make sure that it is balanced? Now let's put 2. If you put 2 here, this becomes 2 times 3, which is 6. And 6 plus 2 is 8. And then calcium for hydrogen here, it becomes 2 plus 4, which is 6. 2 plus 6 is 6. Then let's assume that we also have... In balancing this, sometimes it is trial by error. You try, you write, and you remove if it is not balanced. So if we put here 2, this one alone becomes 8, and plus this one, which is 10. Okay, it is now 10 hydrogen. No, this one is 2 times 4 is 8, plus 2 is 10. Why this one is 2 times 3, which is 6, plus 2 times 2 here, which is 4. So 6 plus 4 is 10. Okay, so it is balanced. Hydrogen is now balanced. Now we move to nitrogen. Nitrogen is... We now have 2 nitrogen here. The right hand side, the left hand side, we have 2 nitrogen. Now here we have 2 nitrogen also, so it is balanced. Then we come to chlorine. We have 2 chlorine, that is 2 chlorine here, and we have 2 chlorine here, so everything is balanced. Therefore, the balanced chemical equation here is so this is the balanced chemical equation for the reaction. Everything, the total number of atoms for calcium is 1, for oxygen is 2, for hydrogen it is total of 2 times 4 plus 2, total of 10. For nitrogen, total of 2. And for chlorine, total of 2. The same thing here. For nitrogen, total of 2. For hydrogen, total of 2 times 3, which is 6 plus 4, total of 10. For oxygen, total of 2. For calcium, total of 1. And for chlorine, total of 2. So we have everything balanced. This is the balanced chemical equation. Now let's also have this example. Now sometimes they may not write the chemical equation for you, they can just give you the names of the chemical equations and tell you how they are reacted, and then your work is to find out the names, the chemical formula for the compounds or the elements, and then write the balanced chemical equation. Now that means that you have to be very good in knowing or identifying chemical compounds and elements and knowing how they react to give whatever they are giving. Now let's look at this example. Now we should balance Now, if you balance this equation, we have ammonia plus copper 2 oxide to give us nitrogen plus copper plus water. Now, if you don't know the chemical formulas for these substances, you cannot balance the chemical equation. So, knowing the chemical formula for all the compounds and their elements an element is very important. Ammonia is NH3. Copper 2 oxide is CuO. Now this gives us nitrogen does not exist as monatomic substance. Monatomic substance is the one that has only one atom. If nitrogen is standing alone anywhere, it must be diatomic, which means that two of it must come together. Just like oxygen, we cannot write oxygen like this and leave it, and hydrogen, we cannot write it like this and leave it in a chemical equation, because these ones, they are unstable. Once oxygen is standing alone, it will look for another oxygen atom to attach to itself to become a molecule. A molecule has two or more of the atom attached together. The same thing with hydrogen. So this nitrogen cannot stand as N. It only exists as N2. That is nitrogen molecule. So if you don't know this thing, you may not be able to balance the chemical equation very well. So these are very important things you should know. Then copper can stand alone. So we have Cu, and then water. The formula for water is H2O. So this is the basics. Now we want to balance. How many nitrogen atoms do we have? We have one here and we have two here. So we have to balance. Let's put 2. If you put 2 here, we now have 2 nitrogen atoms and 2 nitrogen atoms this place. Now for hydrogen, we have 6, that is 2 times 3, which is 6 nitrogen atoms. And we have 2 nitrogen atoms here, 2 hydrogen atoms. Let's put 3. 3 times 2 will give us 6. So we have 6 hydrogen and 6 hydrogen here. Then for copper, we have 1 copper here and we have 1 copper here. Then for oxygen, we have 1 oxygen and we have 3 oxygen here. That is this 3 times 1. We have 3 oxygen. So what are we going to do to balance it? Let's put 3. Three oxygen, so this one becomes 3 times this, which is 3 oxygen here. So we now balance this at 3 oxygen. Now we now have 3 copper, so we have to put 3 here. Now everything is balanced. We have 2 nitrogen, 6 hydrogen, 6 hydrogen, 3 copper, 3 oxygen, and 3 oxygen. So the equation is now balanced. So the balanced chemical equation for that is okay. So this is how to balance chemical equations. Now your assignment. You balance these chemical equations. Okay, so in question number 1, we have this PbNO3 to give PbO plus NO2, NO3 2. 2 we have Na2CO3 plus HCl to give NaCl plus H2CO3. You balance the equations. Then here we have iron plus chlorine gas will give you iron 3 chloride. You balance it. Magnesium hydrogen triazole carbonate 4 plus hydrogen chloride acid to give you magnesium chloride plus carbon 4 oxide plus water. So you balance the equations. Thank you.